The following is the video solution from JSDT Solutions. Question 9.1 says, determine f prime of x from first principles if it is given that f of x is equal to 2x squared minus 3x. Okay, so to determine this from first principles, we still have to find the f of x plus h. So let's go ahead and find that. Wherever we see x, we replace it with x plus h. So this is 2 times x plus h all squared, and then minus 3 times x plus h. And now we simplify. So this is 2, and when this gets squared, you can write it twice and then FOIL it out, but that takes a while. So what we can do is simply square the first term, which is x squared, square the last term, positive h squared, and then first times second term is xh, and then you just multiply that by 2. So that's positive 2xh. And then we can distribute that. So that's minus 3x and then minus 3h. And when we distribute the 2, we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And here's the formula to find the derivative using first principles. Okay, so we're going to substitute. So we're saying that f prime of x is equal to the limit as h approaches 0. And it is all of this. Okay, and this is going to be minus f of x. F of x is 2x squared minus 3x. So you see that that's going to need brackets. 2x squared minus 3x. And this goes all over h. Okay, so this is equal to the limit as h approaches 0. And we'll still have the f of x plus h part. And this is equal to minus 2x squared, because they distribute, and plus 3x all over h. Now, you know that all that will cancel in the numerator. It's just whatever you were subtracting by. So this cancels with the positive of that, and that cancels with the negative of that. So this is equal to the limit as h approaches 0, and we have 4xh plus 2h squared minus 3h all over h. So this is equal to, and now we can finally fix the issue that we would have had with this. H is on the denominator, so we're going to take h out as a common factor so it can cancel with that, and we don't end up with an undefined value. So when we take h out of the first term in the numerator, we get 4x, and then out of the second term, we get 2h, and the third term will be left with minus 3 all over h. And now it cancels. So at this point, you can substitute. It's perfectly fine. So we'll say 4x plus 2. In place of h, we say 0 minus 3. So f prime of x is finally equal to 4x minus 3. And that is our answer. Question 9.2 says determine 9.2.1 dy over dx if y equals this. Now notice that everything is actually ready to be derived, so we can go ahead and derive. So dy over dx is equal to, and we'll say coefficient times exponent, so that gives us 20, and then exponent minus 1, which gives us 4. Same thing, coefficient times exponent, and that gives us negative 24, and then exponent minus 1, which is 3. And then 3 times the exponent of 1 on x is positive 3. And then that exponent minus 1 gives you 0. But anything to the power of 0 is 1. And 3 times 1 just stays 3. And that is our answer. Moving on to the next question. The next question, 9.2.2, we need to derive the function in the parentheses. So let's see. What is wrong with this right now? Well, it has a surd with x. That's a problem. If it had a surd with a number, just like square root 2, that's not a problem because that's just a number. So here we need to fix that. We need to ensure that there is no surd there. And then there is an x in the denominator, and that needs to come to the numerator. So here is what we can do. We can still keep writing dx because we have not derived yet. And then for this, what we're going to do is rewrite it like this. It's still a negative fraction, of course, but the x now will be written like this. We'll say the inside exponent of that x over the outside exponent, which is the number behind the surd. So that is 1 over 3 that we have there, and then that goes over 2. Okay, so that is it for that part. And then over here, this is squared. So one of the easiest ways to work with this is to, well, you could bring that to the numerator, or you could also just work on squaring it first. Okay, it's just a value squared. So 1 squared is just 1, but 3x all squared is 9x squared. Okay, and then we can move it to the numerator. So we have dx, and we still have this, which you can actually write as negative 1 over 2 x to the power of 1 over 3. And then this is going to be plus, and the x moves to the numerator. So we can just call this 1 over 9, and the x is in the numerator now, but because it moved to the numerator, its exponent would change to negative. So it's now negative 2. And there we go. And now we can actually derive. So we'll say coefficient times exponent. So that's going to give us negative 1 over 6x, and then exponent minus 1. 1 over 3 minus 1 is like saying 1 over 3 minus 3 over 3, which is negative 2 over 3. So negative 2 over 3. And then same thing here, coefficient times exponent, which gives you negative 2 over 9, and then exponent minus 1, which is negative 3. Okay, so to see how far we should go, we can just check the mark allocation. It's 4 marks. You get a mark for putting each of it in the standard form for it to be derived. So we get a mark there, 1. And then this one, finally putting it in that form, 2. So that will be 2 marks there. And then you get a mark for deriving it, okay, each of it. So that's 1, 2, 3, and 4. So this is fine. Okay, and at this point, you don't really have to rewrite it in a way that the exponents are positive. You can if you want to, but it's also fine to leave it at this point. Okay, so that is it for our answer here. And that is it for question 9, which is a total of 12 marks.